Hello and welcome to Empowered Learning. This video will be about how to perform a hypothesis test using a t-distribution where we have a summary of data. So we see here in starting off that our claim here is that our population mean, whatever it is at least 7,900 with a level of significance of 0.10, meaning that we have about 90% confidence in this claim. From the population that we're looking at, our sample, we took a sample from that, and that sample says that its mean is 7,600, its standard deviation is 420, and the sample size is 24. And since the sample size is less than 30, then we know that we're going to have to do a t-distribution instead of a z-distribution. So to start off, we need to figure out what are the null and alternative hypotheses. So we know that the null hypotheses will always be the one with the equal sign. So here, since we have a greater than or equal to sign here, this will be the null hypothesis, or the H sub 0. And then, of course, our alternative hypothesis will just be kind of the opposite of that. So we'll have to find something where it says population mean is less than 7,900. So the best choice here would be B. So now we need to find out what is going to be the value of our standardized test statistic. So this is going to be the calculation that we actually use to see is our data going to be in our rejection region or not. And what we mean by our rejection region is statistically, do we have enough numerical data to be able to say for us to either support our claim or go against it. So to do that, we can go to StatCrunch. And let me minimize this to make it a little bit more user-friendly. So coming here, if we go to stat and then go to tstat, one sample with a summary, then we can type in our information here and it will give us an idea of what our test statistic will be. So our sample mean is 7,600, standard deviation is 420, sample size is 24, and we see here that we're assuming our population mean to be 7,900. So we see that this is our null hypothesis here, and our alternative hypothesis would be here. Because of course, if that's greater than or equal to, that needs to be less than. And so now we compute, and we see that we have our test statistic of it's about negative 3.50 if we round to 2 decimal places. So let's go ahead and type that in. All right. So now we need to know what the p-value is. All right, so for our p-value, we see that we have this value of 0.001, so that should be it. So let's go ahead and check and see if that actually works. Okay, great. So now we need to decide whether we're going to reject or fail to reject our null hypothesis. So when we look at this, we know that our value for alpha that is up here actually represents the area under the curve of that particular t-distribution there, okay? And so when we see this, we see that this p-value, which is basically the probability under the area of the curve, is way smaller than the 0.10 here. So this is like 1/10 and this is like 1/1000th. So we see that this p-value here is going to be well within the rejection region. So because of that, we need to reject the claim, which was that our population mean was at least 7,900. So we reject that. And so that means we are accepting the fact that it may be less than 7,900. So we need to find the one here that says we reject the null hypothesis and there's enough evidence to reject the claim. And so I think that would be the first one here. All right. And so that is how we do a hypothesis test.